Hello, this is Bradley Cromar from the Math Department, and this is part 2 of Lesson 24 dealing with inference for bivariate data. And so for part 2, I'll be talking about hypothesis testing and confidence intervals. Okay, so with hypothesis testing, going back to part 1, to the true regression equation is y is equal to beta naught plus beta 1 times x plus e plus epsilon, where beta naught and beta 1 are the parameters, and epsilon is the normal random variable. We are mostly interested in the parameter beta 1, which is our slope. So the null hypotheses, the null and alternative hypotheses are beta 1 is equal to 0 for the null, and beta 1 is not equal to 0 for the alternative hypothesis. So if beta 1 is not equal to 0, then we can say that there is a relationship between the response variable and the explanatory variable. So the response variable being the y variable and the explanatory variable being the x variable. Okay, so to do hypothesis testing, there's 6 steps for doing this with linear regression. Step 1 is state the null and alternative hypotheses. Steps 2, 3, and 4 calculate the test statistic, degrees of freedom, and p-value. Now those items there we can get either from SPSS or Excel. Okay, those will be calculated using computer software. And then steps 5 and 6 are the same last 2 steps we've done with hypothesis testing that we've done before. Reject the null if the p-value is less than the level of significance. If not, then don't reject. And then we state our conclusions. If we reject the null, then we have sufficient evidence to state the alternative in English. And if we don't reject the null, we have insufficient evidence to say, and then we state the alternative in English. Okay? So now let's go through the example of the crocodile data. Is there a linear relationship between body length and head length? And so we'll use a level of significance of alpha equal to 0.05. So step 1 is the null and alternative hypotheses is always stated the same way. Beta 1 is equal to 0 for the null. The alternative is beta 1 is not equal to 0. The test statistic, here's an example from SPSS and Excel, similar output. The test statistic we get down below here in the bottom row of the coefficients table is 35.588. And our degrees of freedom, we would get that on the ANOVA table just up above. That's 20. The degrees of freedom would be on the residual row, and so that would be 26 degrees of freedom. P-value is, it says here in the bottom here, it's 000, but after going through a semester of this, you know it's not exactly 0, so it's close to 0. So since our p-value is less than alpha, we reject the null hypothesis, and we have sufficient evidence to say that beta 1 is not equal to 0. So therefore, we can say that there is a linear relationship between head length and body length. Okay, so let's go through the second example with manatee data. Is there a linear relationship between manatees killed and the number of powerboat registrations? And we'll use again a level of significance of alpha equal to 0.05. So step 1 is state the null and alternative hypotheses. Beta 1 is equal to 0 as the null, and beta 1 is not equal to 0 for the alternative. Test statistic, degrees of freedom, p-value we get from our software. Here's our test statistic, 15.491. Degrees of freedom again is close to 0, or excuse me, degrees of freedom is up here with the residuals. On the residual row, degrees of freedom is 33, and our p-value again is close to 0. And so since our p-value is less than alpha, we reject the null hypothesis, and so we have sufficient evidence. So therefore, we have sufficient evidence to say that the true slope is not equal to 0. Therefore, we can say that there is a linear relationship between manatees killed and the number of powerboat registrations. Finally, confidence intervals. So the true regression equation, so it's y is equal to beta naught plus beta 1 times x plus epsilon. And so we're mostly interested in the parameter of beta 1, or the slope. So when we create a confidence interval, we can say that we are 95 or x% confident that the true regression slope is between the lower limit and the upper limit. Okay. So now here's a couple of examples again with the crocodile data and the manatee data. So with the crocodile data, so it's under the coefficients table. It's on the bottom right. And so when we do a constructed confidence interval, it's on the bottom right. And the lower bound is this number here, and the upper bound is this number here under the bottom row for head. In this case, it'd be head length. And so we are 95% confident that the true regression slope is between 7.218 and 8.103. And since 0 is not in the confidence interval, we can say that the true regression slope is not equal to 0. Okay, 0 is not in the confidence interval. So then the manatee data, if we go again to the bottom right of your table, we say that we're 95% confident that the true regression slope is between 0.112 and 0.146. And again, since 0 is not in the confidence interval, we can say that the slope is not equal to 0. And that concludes lesson 24 of Inference for bivariate data. If you have any questions, please speak to your instructor.